Everybody. My name is Virginie Drugeon. I work for Panasonic, as you can see from the Panasonic logo on the slides. However, this is a presentation of the DVB-UHD specification, so there's actually nothing specific to Panasonic in the slides. This standard, TS111154, has been written mostly by DVB TM-AVC subgroup, so this is really the result of a work effort and of a common effort. And I would like at this point first to thank all the people from TM-AVC who are present here. I'm giving this presentation on behalf of TM-AVC, and I would like also to thank the chair of TM-AVC, Ken McCann, who has managed to lead the group to these results in sometimes rather stressful circumstances. So what am I going to talk about? Mostly TS111154. The little name of this specification is specification for the use of video and audio coding in broadcasting applications based on the MPEG-2 transport stream. As I was saying, this is a specification written and maintained by the DVB TM-AVC subgroup. And we've had quite a lot of work in the last few years. The phase 1 of the DVB-UHD standard was released in June 2015. At the end of last year, in November 2016, we've released the phase 2 after approval by the DVB commercial module, technical module, and steering board. And it's currently published on the DVB website as a Blue Book. A Blue Book is a DVB document, but the Blue Book has been sent to ETSI for formal ETSI publication. In the end, it will be an ETSI standard, the revision 231 of TS111154. It's currently in progress at ETSI, but typically ETSI only does some editorial changes, a comma there, a point there. There will not be any technical changes compared to the Blue Book. This specification references other specification, which I'm sure you have heard of. For the video, it's HEVC or BT2100 for the HDR part. For the audio, it's AC4 part 2 and MPEG-H audio. TS111154 is also referenced by a couple of DVB specifications. I'm going to mention more particularly EN300468, the specification for service information, which is written and maintained by another DVB group, the DVB TM-GBS subgroup, because it contains the signaling for what's in TS111154. So signaling for phase 1 in version 1.15.1 and signaling for phase 2 in the Blue Book 38, which was released at the end of last year together with the Blue Book A157 for exactly the same reason, so that the Blue Books are available in advance to the formal ETSI publication. So an overview of the presentation first. I'm going first to present the video part, video coding technology, resolutions, color primaries, of course, the high dynamic range and high frame rate features, which are the important features in phase 2, as well as the conformance points and DVB-SI signaling. Then I'm going to present next generation audio. I have to warn you that I'm less of an expert in audio than in video. So it can happen that you have questions on audio that I cannot answer. If this happens, please send me your questions per email after the webinar and I'll forward them to the experts. For example, Wolfgang Schildbach, who was the editor for the audio part and who is also on the webinar. And finally, at the end, I'll point to relevant clauses in the actual standard for your information. So let's start with the video part and with phase 1. So DVB-UHD is based on HEVC coding. You can't have DVB-UHD with any other codecs for the moment. It's really all based on HEVC. When we did the first phase back in 2015, we also defined HEVC HD conformance points. So a conformance point in TS111154 is a set of capabilities that a receiver has to fulfill, or a bitstream has to fulfill. So we have receiver and bitstream conformance points. We have 4 HD conformance points for HEVC HD, which I have shown here for the sake of completeness, but this is actually a presentation about UHD, so what I'm more going to explain is the UHD conformance points. For phase 1, we had only 1 conformance point. It's called HEVC UHD IRD in TS111154. This is the conformance point for DVB-UHD phase 1. TS111154 itself doesn't really use the terms phase 1 and phase 2 except in the introduction, but not in the main body of the text. So the conformance point for DVB phase 1 is called HEVC UHD TV IRD. The bit streams can support 8 or 10 bits. The receiver has to support main 10, so it has to support up to 10 bit, of course, main 10 profile of HEVC, main tier and level 5.1 for frame rates up to 60 Hz. Now, the phase 2 is an extension to this phase 1 conformance points. It's still based on HEVC main 10 profile main tier, except now only 10 bits are supported for the bit streams. It adds 2 major features, high dynamic range and high frame rate, which can be used together or independently from each other, which means high dynamic range bit streams can have a frame rate equal to or lower than 60 Hz. High frame rate bit streams, of course, have a frame rate higher than 60 Hz. That's the definition of high frame rate bit streams. So the level is still 5.1 for bit streams with a frame rate up to 60 Hz, but it's 5.2 for HFR bit streams. In terms of resolution, for phase 1, we had defined a whole list of resolution, UHD resolution, of course, other resolutions between UHD and HD, HD resolution, and sub-HD resolutions. We don't really call this resolution SD because, as I'm going to explain in the next slides, the colorimetry is still the colorimetry of HD. So we prefer to call that sub-HD rather than real SD-TV. As you can see, for most of the resolutions of the formats in this table, it's progressive scan, except for 1080, where you can use interlace scan for phase 1 only. In case of phase 2, we have reused exactly the same spatial resolutions, except with some changes. We've removed the support for interlace scan. No interlace scan in DVB-UHD. This is the past. And we've removed the support for non-square pixel resolutions. So we only have square pixel resolutions. And in addition, we have added support for 100 Hz and 120 Hz frame rate in case of high frame rate. I was mentioning the colorimetry. For phase 1, we have 2 colorimetries supported, BT709, which is the HD colorimetry, and BT2020 non-constant luminance, which is the UHD colorimetry. Other colorimetries are possible, but optional. It means there is no guarantee that the receivers are actually going to be able to interpret them correctly. Now, this UHD colorimetry, BT2020 colorimetry, called sometimes white color gamut, is in phase 1 for us. But what does it mean that it's in phase 1? It's actually the signaling for BT2020 non-color luminance, color primaries, and matrix coefficients that is supported already in phase 1. It does not say anything about the color capabilities of the display. The color capabilities of the display and the mapping to the color capabilities of the displays are not defined in TS111154. This is outside the scope of TS111154. So it's really up to the manufacturer how to map the color capabilities, the colors of the signal to the color capabilities of the display. As I mentioned before, the support for SD-TV is not mandatory because the colorimetry is not mandatory, so only sub-HD resolutions are supported rather than real SD-TV. No full range video. This is standard 420 chroma sampling only. Again, standard, and it's the only chroma sampling supported by the main and maintained profiles of HEVC anyway. And the transfer characteristics for phase 1 is the one from BT709 and BT2020. The same, it's typically the standard dynamic range transfer characteristics. Now for phase 2, we've removed, at least for the bit streams, we've removed the support for HD colorimetry. So the bit streams that are phase 2 should only use BT2100 non-constant luminance colorimetry. It's exactly the same as the BT2020 colorimetry. It's what we call UHD color space. We have referred to BT2100 because it's the latest ITUR standard. I'm sure you're familiar with it if you know a bit about high dynamic range, but it's really the same as the same color space as in BT2020. Again, same as for phase 1, only the signaling of the color space and matrix coefficients has to be supported. The actual color capabilities of the display are still not within the scope of TS101154. In that case, only sub-UHD resolutions are supported rather than real HD formats, because the BT709 colorimetry is not supported for phase 2 bit streams. And only narrow range BT2100 is supported. So that's for the general features of phase 1 and phase 2 DVB-UHD bit streams and receivers. Before I go more in details into the details of high dynamic range and high frame rate, I can start answering questions. Okay, I don't see any questions. Okay, there doesn't seem to be any questions. If there are no questions, I'm going to continue the presentation. If you have questions in the meantime, you can just write them, and at the next question slide, I can answer them. So let's move to high dynamic range, which is one of the main features, or the main new features for DVB-UHD phase 2. In TS11154, we have defined two solutions for DVB-UHD high dynamic range, PQ10 and HLG10. These are basically new transfer functions. If you are familiar with the standard BT2100, you probably heard about the PQ system and the HLG system. Basically, the PQ system defines the transfer function more on the display side, whereas the HLG system defines the transfer function on the camera side. So both are single-layer HEVC maintained bit streams. The first solution, PQ10, is not supposed to be backwards compatible to DVB-UHD phase 1 receivers, whereas the second solution is decodable by DVB-UHD phase 1 receivers as standard dynamic range. I'm going to explain a bit more in detail afterwards. First, I'd like to concentrate on the first solution, the PQ10 solution that defines the EOTF, the electro-optical transfer function. In the case of the PQ10 solution, you can also transmit optional metadata in the bit stream that can be used for adapting the signal to the actual characteristics of the display. Optional metadata, in that case, means both optional for the bit streams to carry and for the receivers to interpret or not. More specifically, in this case, we mention in TS11154 two SCI messages that are specified in the HEVC standard, which are the mastering display color volume SCI message and the content light level information SCI message, typically named static metadata in the HDR community. The mastering display color volume SCI message typically transmits information about the mastering display that was used for processing of the content, and it may help improve color reproduction of mastered content when shown on other display than the mastering display, which is very likely because not everybody has a mastering display in their homes. The content light level information SCI message carries information about the signal itself, like light level of the video content, for example. These two specific SCI messages are mentioned in TS 101-154. It does not mean that these are the only ones that are allowed. Of course, you could use other SCI messages specified either in HEVC itself or in other standards, but they are not mentioned in TS 101-154, which means you have no guarantee that there is any interoperability for them. You have, if it's an external system, DVB doesn't guarantee interoperability, but it does not preclude it either. Now, going to the backwards compatible solution, HLG10. So what do we call backwards compatible in the sense of DVB? There were many discussions about this term. For us, it means the capability for a new UHD phase 2 bitstream to be decodable and displayable by already standardized DVB-UHD phase 1 receivers. In that case, the solution we adopted is the hybrid log gamma OETF. It has some kind of native backwards compatibility of the transfer function because the first part of the transfer function is the same as the standard dynamic range transfer function. So it can be given to a display that only understands the standard dynamic range transfer function, and the result is at least acceptable. It's an easy backwards compatibility because no change to the HEVC coding is necessary. There is no need to have dual layer coding or anything of that sort. It's only new signaling that is needed. So what we discussed about what backwards compatibility means in TM-AVC. In that case, it's a system that is for HDR focused delivery. The SDR part is in addition. You have some kind of backwards compatibility. It's not perfect, but it's good enough. So the quality of the SDR image is acceptable. It might not be exactly the same kind of SDR image that you would have had if it was a signal that was graded for SDR. Now, in terms of signaling for these two solutions at the video elementary streams level, it's basically very easy because the only thing you have to signal is just a new transfer characteristics. Now, in the sequence parameter set in the HEVC standard, there is a structure called video usability information, typically containing information that's not necessary for decoding but important for displaying. That also contains the color primaries and matrix coefficients, for example. And there's a field in this structure called transfer characteristics. For PQ, it's very easy. You just have to send the value 16 for this field. For HLG, it's a bit more complicated because the signaling has to be backwards compatible as well to be able to use the backwards compatibility of the transfer function. So in that case, the transfer characteristics in the VUI still signals the DT2020 transfer function, the standard dynamic range transfer function for existing receivers, for phase 1 receivers. But in addition, an alternative transfer characteristics SCI message is sent with every random access point that contains a preferred transfer characteristics field that signals the value 18 for HLG. It's basically meant as overwriting the transfer characteristics field in the VUI for receivers that do understand this syntax, obviously. So obviously, this SCI message has to be used in combination with the information in the VUI. We haven't written that specifically in the standard, but I've been asked since the standard has been published. I think we meant to say that this SCI message has to be transmitted as often as the sequence parameter set is transmitted, but that's my interpretation of it. We've not actually written it in the standard, but obviously this SCI message only makes sense in combination with the information in the VUI. We have also defined some signaling for dynamic switching between HLG10 and SDR and between PQ10 and SDR. it's very straightforward. What you can imagine, the value of the transfer characteristic simply changed. And dynamic switching should be seamless for the decoding, but not necessarily for the display. Again, TS111154 is about decoding, not about display. So the display can go black. So these are the main information for HDR. Are there any questions at this point? So I'm checking the Q&A. I don't see any questions at the moment. Okay, so this is going to be very easy. There are no questions. In that case, I'll continue with the high frame rates part. So high frame rates means the support for frame rates 100 Hz and 120 Hz, both fractional and integer. Dynamic changes of frame rates within a service are allowed, but only for doubling or halving of frame rate, which means you can change between 50 Hz to 100 Hz or vice versa, but you cannot change between 50 Hz and 120 Hz or between 60 Hz fractional and 120 Hz integer. That's not possible. Again, same as for high dynamic range, we have two different technologies for high frame rates, one that is backwards compatible to UHD phase 1 receivers and one which is not. In case the backwards compatibility is not necessary, the HFR bitstream is transported in single PID of the transport stream. In case the bitstream is intended to be decodable by UHD phase 1 receivers at half frame rate, obviously, temporal scalability is used. Two bitstreams are produced using temporal scalability and are packed into two different PIDs of the transport stream. It makes it very easy for phase 1 receivers because the MPEG-2TS parser of the phase 1 receiver can just pass the packets, discard the additional PID, and only keep the PID of the base layer, which has to fulfill the level 5.1 constraints. So a bit more about that. As I was saying, we are using the HEVC temporal sublayers tool of HEVC with signaling based on temporal ID. The base layer called HEVC temporal video sub-bit stream, and by the way, this is not a term that we invented, we took it from the MPEG-2TS standard. This HEVC temporal video sub-bit streams only has a frame rate up to 60 Hz, and each second frame in between are coded in the HEVC temporal video subset that brings the whole bit streams to a frame rate up to 120 Hz. Only the frame rate is changed, is doubled actually in these two bit streams. All other video characteristics such as bit depth, resolution, colorimetry stay the same. So for example, there is no spatial scalability. It's only temporal. The sub-bit stream, this kind of base layer, if we could call it that way, contains all the random access points, of course, so that phase 1 receivers can start at a random point in the bit stream, has constant rate of decoding timestamps that is equal to or lower than 60 Hz, so as not to upset phase 1 receivers, and conforms to the limits associated with level 5.1. Within a service, the value of the temporal ID for the HEVC temporal video sub-bit streams is fixed, so that the temporal ID max of the sub-bit stream does not change in case of switching to lower frame rate, in case the HEVC temporal video subset disappears, basically. It makes it also a bit easier for phase 1 receivers. So that's it for high frame rates. Are there any questions at this point? Okay, so I see a question about the HDR part. What about the transitions between SDR and HDR? As I mentioned before, the transition is possible by just switching the value of transfer characteristics. So for SDR, the value is 14. For HDR, it's 16 or 18, depending on PQ or HLG. By just switching this value at a random access point, obviously, it's possible to switch between SDR and HDR. I do not expect many changes between SDR and HDR within a service. This wasn't actually one of the commercial requirements that we had originally. It's a feature that we added afterwards in the standard. Then I see a question. For older display between T709, only addition is SCI preferred transfer characteristics to 18. Well, as I was saying at the beginning, UHD display should be able to understand BT2020 anyway. So yes, the only addition is the SCI preferred transfer characteristics. We assume that phase 1 receivers have done things correctly, and when they receive a BT2020 bitstream, can map as good as possible to the actual color capabilities of the display. I have a question then, why have 2 solutions for HDR been selected rather than 1? Did people not agree? That's not the reason. We clearly had as commercial requirements that we needed 2 solutions. One which would be backwards compatible, one which would not. The idea was, if you have a non-backwards compatible solution, it might be more interesting for certain markets. So that's why we had 2 solutions. Basically, our commercial requirements told us to select 2 solutions. Then I have a question, is Full HD 1080p HFR also considered as UHD phase 2? Yes, basically yes, any HFR bitstream is UHD phase 2. Then single PID HFR is also okay in streams. Yes, that's correct. Again, for HFR, same as for HDR, we have to define 2 solutions, one that is backwards compatible and one that is non-backwards compatible. For non-backwards compatible, we can use a single PID, of course. What about HDR to SDR in HLG? So in HLG, again, it's very clear in TS111154. You keep the SCI message, but you switch the transfer characteristic, the preferred transfer characteristic field to value 14. If you don't see transitions from SDR and HDR being done often within a service, do you expect adverts to be HDR for HDR services? I don't know. This is a commercial question. It's possible to have both with the standard, I think. Okay. So I think I've answered all questions that I saw. Oh, I see another question. How will an HEVC encoder read the information to put into the SCI and VUI messages? Any standardization there? Basically, no. That has to be handled by the encoder. So responsibility of encoder manufacturers. I see a question. So the video parts of DVB-UHD1 Phase 2 and ATSC 3.0 candidate standard are the same? Well, I don't know. I don't know about ATSC 3.0. What is the additional bitrate with 2 PID for HFR? Very good question. It depends on the content, as often with video coding. There were some tests performed that were saying 20% at one point, but it's a couple of years ago already, so I don't know if it's still relevant, if it's still the case. It will depend on the encoders. Okay, so I suggest we move on. I think I've answered most questions. So the next part is about conformance points and signaling. As I was saying, we have defined receiver conformance points and bitstream conformance points in TS101-154. In case of receiver conformance points, it's the set of features that a receiver has to conform to. A receiver can conform to several conformance points. It's not exactly like a profile. It's perfectly possible to conform to several. In case of HDR, we have actually 2 conformance points. An HDR conformance point using PQ10 and an HDR conformance point using HLG10. So it's perfectly possible for a receiver to support either PQ10 or HLG10, but it's also possible to support both. Typically, I expect at least the first receivers will probably support both. And then on top of each one of these 2 HDR conformance points, we've created HDR HFR conformance points. So it means concretely that any high frame rate capable receiver is also expected to be high dynamic range. But an high dynamic range capable receiver is not necessarily a high frame rate capable receiver. In terms of bitstream conformance points, it's a bit more complicated than that. There are 9 bitstream conformance points for the whole of DVB-UHD. The one on the top left, the blue one, is actually phase 1 bitstream. Then on the right, you have the HFR bitstreams with the 2 possible technologies, dual PID and temporal scalability, which is the backwards compatible technology, and single PID, the non-backwards compatible technology. On the left part, you have the 2 HDR technologies, HLG10 and PQ10. And of course, when both HFR and HDR are used in a single bitstream, you have every possible combination of these 4 technologies. The bitstream conformance points in orange are the ones that are backwards compatible to phase 1 receivers. They can be decoded by phase 1 receivers, typically at half frame rate or as standard dynamic range. The red ones are the non-backward compatible ones. Now, I mentioned at the very beginning of the presentation EN 300-468, the service information. In DVB-SI, we have tried to define signaling for each one of the bitstream conformance points identified in TS101-154. Concretely, this is done by using the service type in the service descriptor and the stream content and component type in the component descriptor. We've introduced one service type, the green service type X1F, and 4 value of stream content and component type for phase 1. So these are the existing value for HEVC HD and UHD phase 1 bitstreams that we had defined back in 2015. These values are the ones that you should use also to signal backwards compatible bitstreams, because obviously these are the values that are understood by phase 1 receivers. So that's the one you need to use for backwards for bitstreams that are supposed to be decoded by phase 1 receivers. And then there are new values, hex 20, service type hex 20, and 3 more values of stream content component type for phase 2 bit streams that are not backwards compatible. Plus some new informative values for signaling in the additional information about phase 2 bit streams. Typically for the backwards compatible bit streams, they will use the green values plus one of the purple values to give some more information. So concretely, it means that the green values are mandatory for the phase 1 bit stream and the backwards compatible phase 2 bit streams, and the red values are mandatory for the non-backwards compatible phase 2 bit streams, plus some additional optional component descriptors. For example, in the case of HLG 10 bit stream, an HDR only HLG 10 bit stream, you can use one of the component descriptors that tells the receiver you can decode it if you are a phase 1 receiver, but by the way, if you're a phase 2 receiver, this is also an HLG 10 bit stream. So that's for the signaling. Any questions at this point? Okay, I see no further questions. So I'm going to continue. This is it for the video part. So I suggest we move to the audio part, next generation audio. So what is next generation audio? It's the flexibility to create and deliver content with new concepts and techniques. Typically immersive audio with the addition of a loudspeaker in the high. For that you need some metadata to describe the properties of the different audio tracks, and personalization option with the concept of audio preselection that I'm going to explain. And audio objects are basically objects to facilitate the immersive and personalized audio features. So if you look at the diagram on the right of the slide, typically an audio program in next generation audio contains audio program components that carry audio information like the background, dialogue in English, dialogue in German, audio description in English, some other dialogue. And then you have some metadata in the form of audio preselection in the case of personalization. That gives you a default preselection that points at the relevant audio program components for this particular preselection. So in the case of the default preselection, it will be the background and the English dialogue, for example. In the case of the German preselections, the background and the German dialogue, and so on and so forth. So in terms of TS11154, we've defined a number of concepts in the standard that are used for all NGA codecs, which are 2. So an audio program, which is a complete collection of audio program components and a set of accompanying audio preselections, which are basically metadata, as I explained on the diagram before. An audio program component is the smallest addressable unit of an audio program. Audio preselections are a set of audio program components, or it describes a set of audio program components representing one version of the audio program. Audio preselections is the general term, but each codec is actually using its own term for this concept. It's called audio presentation in AC4 and audio preset in MPEG-H audio. And there is one default audio preselection to be decoded when you don't know which one to be decoded. In terms of transmission of this audio program, it's transported in an NGA stream, which is basically a stream containing one or more audio program components of one audio program. There are 2 transmission modes: single stream delivery, one stream carries all the audio program components, and multi-stream delivery, where you can have several streams carrying several different audio program components. In the case of the multi-stream delivery, you have one main NGA stream, which is basically the stream that contains at least all the audio program components corresponding to the default audio preselection. And you have auxiliary NGA streams, which basically contain the other audio program components, those that are not contained in the main NGA stream. So we have defined two codecs, ETS11154, that fulfills these concepts for next generation audio. AC4 Part 2 is an extension to AC4 Part 1, which was already present in TS11154. And MPEG-H audio, more specifically the low complexity profile level 1, level 2, or level 3. Both codecs support single stream and multi-stream delivery of audio program components, as I've just explained. Both codecs support dynamic range and loudness control metadata. And we had many discussions about rendering. We've written similar wording for renderers for both codecs. A reference renderer is of course important because it provides broadcaster a tool to verify the rendering performance of the signal, but this reference renderer is not necessarily implemented at the IRD and will not necessarily be used to render the signal in all IRDs. Important is it's written that it is recommended that the IRD implements either the reference renderer or a renderer that performs at least as well as the reference renderer given the capabilities of the IRD. Where you have to know that it's the responsibility of the manufacturer to check that their renderer performs at least as well as the reference renderer. Now, in terms of specifics that are specific to AC4 and MPEG-H audio, I should mention that AC4 also offers audio-video frame rate matching. And specific to MPEG-H audio, you should be aware that there are some deviations from the actual MPEG specification. Specifically, the object and HOA renderer defined in MPEG is not mandatory. As I've just explained above, it's a recommendation to use it. And some of the features defined in MPEG are optional. These features being user interaction interface, generic loudspeaker rendering, format conversion, immersive rendering, and binaural rendering. Same as for video, there was some values defined in DVB-SI to signal these NGA streams. More specifically, stream content and component type values in the component descriptor. Two new component types values have been defined for the two NGA codecs, plus additional value of component type that can be used to indicate some specific NGA features, such as if the content is pre-rendered for consumption with headphones, if the content enables interactivity or dialogue enhancement, if it contains spoken subtitles or audio description, and the preferred reproduction channel layout. Other tools you can use for signaling at the PMT level in the transport stream are two codec-specific descriptors, an audio preselection descriptor that can be used for the two codecs to signal some information about the stream, like the languages, interactivity, audio preselection, and a stream identifier descriptor for identifying the auxiliary NGA streams in case of multi-stream delivery. Any questions on the audio part? Let me check the questions. So I see a question, does SCI signaling are mandatory with SI signaling? Yes, basically. So yes, the SI signaling is really for the for things like the service list or for the television to decide if it's going to be able to decode the service or not, but the signaling at the video elementary stream is very important for the decoder itself and to correctly display the video. So in case if SCI signaling means the transfer characteristics, for example, for HLG, yes, it's mandatory. There is another question, what is interactivity for audio? I'm not sure I understand the question, but I would say in this case, it's really a possibility for the user to decide which pre-selection to choose. So you can decide if you want to have the dialogues in English, in German, in French, any that is available, or you can decide to have the audio description. You can also decide to have dialogue enhancement, which is changing the level, the loudness of the background compared to the loudness of the dialogues. This kind of features I would call interactivity. I hope it answers the question. Okay, that's the questions I see for the moment. So please, Feyo, can you tell me in case I miss any question? I suggest to continue. I'm almost at the end of the presentation anyway. The last part is just for your information, pointers within the standard for you to know where to have a look at if you're interested in actually reading the standard. So the HEVC profile is defined in section 514. The first subsection, 514.1, is really general HEVC profiling for DVB. Things like you have to signal the color primaries, you have to signal the transfer characteristics, you have to use some SCI message like picture timing SCI message, and you have to signal random access points and the exact definition of a DVB random access points, which is slightly larger than an HEVC IRAP. So things like that basically apply for any DVB HEVC bitstream. Then the other subsections are for the particular conformance points that I've presented in this presentation. More specifically, section 514.3 is the clause describing the DVB-UHD phase 1 conformance points. And the two new clauses in the latest revision are 514.4 and 514.5, which are describing DVB-UHD phase 2. 514.4 being the HDR conformance points, and 514.5 the HDR HFR conformance points. For next generation audio, the two new codecs are defined in section 6.7 for AC4 and 6.8 for MPEG-H audio, with an informational NXK for next generation audio overview. At this point, I would like to point out that TS11154 does not mandate to use any video codec together with any audio codec. Basically, video codecs and audio codecs are completely orthogonal for TS11154. So it's perfectly possible to use HEVC codec, DVB-UHD HEVC, with an older audio codec like AC3 or MPEG-4 AAC. It's perfectly possible. Vice versa, it's also possible to use one of the new NGA audio codec, AC4 MPEG-H audio, with one of the old video codecs like H264 AVC. At least in terms of TS11154, audio codecs and video codecs are orthogonal. Any audio codec can be used with any video codec. Now, in the different regions, it's possible, of course, that in different countries it's grouped together and that NGA codecs have to be used together with HEVC, but this is not mandated by TS11154. Okay, so I've reached the end of my presentation. I'm going to check if there are some more questions that I missed or some additional questions. Okay, so I've seen several questions about if this presentation will be shared. So it's my understanding that Feyo will send the presentation to the participants after the webinar, if I understood correctly. Maybe Feyo can confirm or not. If you have more questions about TS101154 or DVB-UHD standard in general, you can send me an email so sending it to me, writing Feyo and Peter Siebert in copy as well. Especially if it's more of a commercial question rather than a technical question, it's probably better to send it to Feyo or Peter. I'm more answering technical questions. In case it's a question about audio that I cannot really answer, I'm very happy to forward it to the relevant people in TM-AVC.